Hey guys, let me just help you understand how exactly this quantization in large language model is going to work. Now, this is one of the common requests that I would get from most of the learners who are actually starting their learning journey in large language model. So in this video, I'll help you understand this quantization with the help of a very simple story. So let's consider a very simple story. So let's try to understand as how quantization saved the mouse. So let's look into this cat and mouse story and how exactly this quantization saved it. So one of the challenge that we had with this mouse is now this mouse that we have got in the story, it's an overweight mouse. Now it's an overweight mouse. Now, if it is an overweight, what is it that have to do? Let's say if it has to go and pick up the cheese, it requires more energy to move because it's an overweight mouse. And then even if it tries to run, it cannot take a longer step. So it has to take the shorter step. And when it is taking the shorter step, because the size is very large, it will get caught from the cat. And finally, even when it try to manage to get the cheese or reach the cheese, it will obviously alert the cat. So that's the challenge that this mouse is facing. Now, what exactly did this mouse did? So what it did? So it just went ahead and it just joined the gym. So just like we'll join the gym. So it joined the gym, it reduced its weight. Now what it can do is it can now move discreetly without alerting the cat. Now, along with that, so since it has reduced the size, so it has reduced a bit about its ability to carry the cheese because if the body size is large, then there was a chance that it could carry more cheese. Now, since it has slimmed down a bit, it has reduced a tiny bit of the ability to carry the cheese. So overall, the good news is now the mouse is able to get the cheese without alerting the cat. So that's the moral of the story. If you get fit, if you reduce the weight, then there's a very high chance that you can get the cheese. So if I want to give you a quick summary in technical terms, so what has happened earlier, the mouse was an overweight mouse. Remember, the size is more. And it tried to run in a continuous motion because it has to move in a continuous step, that is, in a tiny measured step. Then what it resulted? It resulted in getting caught. Now, what it did, it went to the gym and it became a fit mouse. So it has reduced its size and now it is able to take the discrete steps, which we also call it as the quantized step, in order to avoid getting caught. So that's a key summary in the technical terms of what has happened right now in this cat and mouse with the cheese story. So, so now that you have learned about this cat and mouse story and you got the overall idea about what has happened, now with this story, let's understand what is quantization in large language model. It's a technique that we would use it to reduce the size and computational demand of large language model by lowering the precision of their numerical representation, which are nothing but the weights and the activations of this large language model. That means whatever the weights and the activations that we were representing earlier with the help of floating point values, we will now be representing with fewer bits, with the fewer bits to represent each number. So this will lead to smaller models, which requires less memory and processing power. Now, why do we want to do this? Well, the reason that we prefer to do this quantization because this quantization will significantly reduce the size of large language model. So this will make them easier to store and deploy the large language models. And most importantly, faster inference. So with lower precision models, it can run faster. It can result in quicker responses from the large language model powered application. And it also an energy efficient, and this will also increase the accessibility. Now, one of the main challenges that we would face when we are dealing with large language model is its size. If the model size is, let's say, 16 GB of GPU, then you cannot deploy it on the remote devices where it has got the limited memory. But if we apply the quantization, this will enable the large language model to run on less powerful hardware, which makes them accessible to wider range of users and use cases. Now, how does this quantization is going to work? See, the way that we are going to do is when we talk about the large language model training, now this training of large language model will be done with the help of high precision floating point numbers, that is floating point 32 or 16. Now, in the case of this quantization, once the training has been performed, we are going to convert the model weights and the activations to the lower precision representation. It can be int 8, int 4, and in some cases, we'll also represent with int 2. Now, as a result of this will result in reduction in memory size of the large language model. And because of this reduction in size, this can also be done, that is, the inference can also be done on the less powerful hardware because of its reduced size and computational requirement. Now, let me give you a very simple demonstration as how this quantization is going to help us in reducing the size of the model as well as increasing the inference speed. Now, for the demonstration of the same, I've already implemented in this notebook. This is how the implementation file would look like. To start with, I've imported the model from my Hugging Face repository. Now, this is the Distilbert base uncased, which is trained on the intent classifier dataset. Now, if you take a look at it, currently, if I compute the benchmark, the size of this model is 255 MB and the average latency is 106.90 ms and the accuracy is 0.854. Now what I've done is I've imported the quantized dynamic function from torch.quantization and I have applied this quantized dynamic on the model that we had got earlier. So I've just imported the same model and I have applied this quantization using the int8 format. Then I'm going ahead and perform the same model right here. I'm just calculating the performance benchmark. And if you take a look at it, here, the model size is now just 132 MB. That means we were able to reduce the size of the model to close to 50%. And observe closely, the average latency is 24.06. So which means it is 5 times faster than what we had earlier. And if you take a look into this accuracy on the test set, so it's actually almost similar, or it's little better compared to what we had got. The accuracy on the test set is 0.86, that is 86% of accuracy. So the moral of the story is, if we have a large language model, if we apply the quantization, we can faster, we can get the faster inference without much compromising on the accuracy of the model. So with this knowledge, go ahead and apply to the large language models that you have got. There are various functions. So one method that I've used is the dynamic quantization method. Now there are other quantization methods as well that's also available as part of the Hugging Face library. Go ahead and check out the same and let me know what you think. Now, if you're someone who haven't checked out our courses on the NVIDIA certification and the AWS certification, go ahead and check out the courses at manifoldAIlearning.in. We have got some amazing courses that we have got with us. There are some NVIDIA certification courses, AWS certification courses on generative AI, and there's a Mastering the Generative AI package, which includes some of the amazing courses that we have got at Manifold AI Learning, the MLOps Masterclass, the LLM Ops. Go ahead and check out for some exciting learning at Manifold AI Learning. So thank you so much for watching, guys, and I'll see you next time.